TVs, right?
Or we're live
Wait.
streaming.
Oh, yeah, no, it records when you do it this way.
Okay. Sure. Just make sure you send it to Ethan to get it on Bitcoin TV too.
Yeah, I'm gonna be
nice...
backing. Yeah, I'm also gonna be backing everything up from Bitcoin TV to YouTube, so it'll be on both.
Cool. Okay. Yeah. So made some milestones. So if you want to find milestones, go to pull requests and hit milestones over here. So made we I think we had a 0.1 thing here.
Yeah.
Huh?
I don't see you sharing anymore.
I got rugged. So yeah, so I made some milestones, and if you forget where milestones are, I always, it's a little tricky to remember. So you just hit that milestones button. You got to be on the pull request tab and then hit milestones. So we've had a couple in the past. Like these were all sort of like attempts at making a 0.1 release, and we ended up solidifying on that one. We completed everything, I guess, and we closed this one because we just wanted to get a more concrete milestone, but maybe there's stuff in here that we should still get in. So, we didn't like delete it. It's still here, but so I made 2 milestones originally, 0.2 and 0.3. And then we were thinking like specifically like what could, so I was thinking it'd be good to have it kind of done roughly by the end of the month. So I put just November 27th, that's a Monday, where we could try to cut the first release, including Aleph BFT. That's the big improvement. Yeah, and then so I ended up splitting 0.2.0 and in splitting out stuff that we could apply backwards compatibly to 0.2.1. So this could be 0.2.1, 0.2.2. Maybe I should just call this 0.2.x or something. But this is like everything else that we could add later, just trying to make the scope here as small as we can. And then 0.3 is like for big projects that are in the future, right? I don't know, like Tor, Schnorr support, Schnorr signatures, next generation Lightning integration that Josh has started. So those are like kind of out of scope for the next release. So yeah, we can. So you can just hop into these, I'll maybe look at that a little more. But I also created just a project board that basically just takes the issues in here and then groups them by milestones. So we have they're by 0.2.1, 0.2.0, 0.2.1, 0.2.3, and then in each one of these they're sorted by priority. So I just added like my rough sense of which ones are higher priority, which ones are lower priority. Open to feedback here. But like this one is like by far the biggest one, right? Like sometimes we have successful transactions where money disappears because we misinterpret JSON RPC error cases, or we have a retryable error and we don't retry. I think there's like 1 or 2 of these that we're aware of that we just really need to fix that. Having like a more comprehensive backup and recovery system, so it's not just kind of the eCache module. Just having like being able to do one-of-one federations again is just really nice to be able to have people get started easy and kind of test out Fedimint without having to organize a federation. Now this one, driving all clients from all secrets from the root secret makes kind of goes hand in hand with this. But doing this actually makes it. Ethan asked, should we expect everything to be assigned a milestone? Maybe someday that would be nice. I'm trying not to optimize it too much. I'm mostly trying to get like the big ones in here, right? Like if it's like a bug report, we could. I mean, in the future that would be nice, but I'm not striving to do that yet. Like there's some things that are not, but I think that's a good thing to get to eventually. But kind of iterate there. That a fair assumption.
Yeah, that makes sense.
I don't want to overkill the process here, and then we don't do it. I just want to make sure we have kind of the high level stuff covered. We have a panic that you can hit in the wallet module on the server side. So this could cause, Fedimint D to need to restart if Bitcoin D isn't around. Being able to say which gateway can register a federation is nice, just so you can't have like like crappy gateways joining your federation and ruining user experience. And then, more logging. These are just like slightly lower priority, like make the recovery tool work with ALF-BFT. There's like a handful of these ones, and then like this user-defined fee rate would be kind of nice. So this is what I had here, and then some other ones. So I think maybe in the next dev call we should spend a little time just checking if everyone wants to be the same or is on kind of the same page here. If we should move anything up and around, or if we're missing anything. So yeah, I just encourage you guys to take a look at these, especially this first one, and think about if anything else should be in here, like given that we have like roughly a month to do this. Yeah, any comments here? Nope. Well, that's it for this. Yeah, we'll try to. Well, I'll start covering these on the Monday calls. So I think this is going to be a little more of a Monday thing, just to just keep track of where we're at and prioritize stuff.
I guess I'm curious, like, so assigning 2 milestones, will there be like a group consensus on that, or is that going to be more on like an individual, like just assign it to what milestone you hope to see the issue in, or?
Yeah, I mean, I'm fine if we do it like if you think something should get in, like just propose it in here, say, hey, I added this milestone, and then on Mondays we can kind of review it. I just want to make sure we don't have 30 things get added to the milestone, and then we can't get them all. So sometimes I'm going to take make executive decisions just to make sure we can get the big ones, maybe, or Eric might, But yeah, I mean, I want it to be a group consensus thing, is given that we don't get just as long as we don't bike shed it too much, right?
Yeah, makes sense.
Cool. All right, well, that's it for me. Do we want to discuss the client issues?
Yeah.
Cool. So which one? I mean, there's kind of 3 of them that I was interested in. Let's see. Yeah, so I posted those 2, and then there's also the one from Sharia about taking an external secret. It might be kind of interesting.
Maybe Sharia, if you want to, maybe you can start.
Why don't you do this today? I can do that next time. I'm starving.
Okay.
In meetings, just trying to cook some while I watch.
Okay.
Thank you.
Just finished my Cheerios, so I'm good to go.
Glad everyone's getting fed.
All right. You can see my screen.
Yeah.
So client module. Client module, if you look at its methods, pretty often it will take stuff like this. The DB takes is probably this here. I started adding the leaf federation, and again, I need to repeat it. And it's pretty clear to me that the client operates in a context. As a module implementation, you don't just want an access to whatever your module, your client module kind of created for itself, but you're working in a context of a bigger client, and that's why, like this executor, for example, we need to somehow expose it to the code so it's able to interact with executor. So it's kind of clear to me that we're missing this abstraction of a client context, and it's a little bit like what we did for where's the init one? Before on init, we had like, I don't know, 9 fields we were passing when we are creating new module instance through the init, and then we just kind of moved it all into a struct as an abstraction. So now we can add more of stuff there without breaking the downstream implementations that don't care about the new fields. So now they're just methods on like one big struct. So it feels to me like this is kind of like that. And what was it, mint X? What was it called? You can mint client X. Where is it? Yeah, there is. And you can see it because of this like kind of extended trait. So since the modules themselves cannot implement everything with what they get in the module itself, we create this extension traits for every module just so we can implement oh, why is it already here? Oh, I thought anyway, I think I already have some changes that or did we land it already? Anyway, yeah. So we're implementing on the client the methods for a client module because we actually need the client to be able to perform certain operations. So this is kind of my my motivation. I would like the client to get some kind of a handle to the overall context of a client, so we can move all those methods to be on the in this case Mint client module itself. Yeah, and that's kind of the context of what I'm trying to do here. Is that kind of clear? Anyone have any questions?
Is it mostly about eliminating just boilerplate, or are there any other advantages? Like would moving it over allow us to do new things at all, or is it mostly kind of?
I think it will allow us to do things that are not possible before. So my goal is for the module instance itself to get injected a handle. So then it would get the access to things like executor, and possibly it could even store it in a way somewhere inside it. So it could call the executor from like task it starts and things like that. So it wouldn't be limited just to this. Though maybe for the executor it could actually store it or not. Yeah, I think it's in 90% of it is going to be usability and kind of the UX of implementing client modules and also calling them. But there might be certain minor things that will be now possible that weren't before. So if there's no more questions, then we can kind of look through the PRs itself. What PRs did we have there? The first one was 3466. Let me just glance. Okay, so this one already landed. Okay. So this one is already in the code. So look at oh, where's my arc? Okay. So before, should I just show the div of it, or how? What's the best way to move to new window? Let's look at this PR. Might be the easiest to look at the div in the view here. So before this thing was merged, we had this struct called client inner, and that was actually kind of the client itself. So after it lands, it's called just client. Before this was client inner, right? I renamed it because yeah, in this PR I actually move all the methods from before. We had certain methods that were implemented on the client and then on the client inner, and the client inner was private, but a lot of functionality from the outer client, which is just an arc over the inner client, were delegated to the client. And what I kind of want to start with is that the reason this this context is a little bit of a difficult thing to implement is because of circular dependency. So the client consists of where are the modules? Of modules, of client modules. So you need to create every client module, but you cannot give it a context because the final client is gonna be part of that context. I hope I'm kind of wording it right. So the client needs an access to something it's a part of. And that's a circular dependency, and then it's the Rust without garbage collection is reluctant to let you do things like that. So for this not to be kind of one big memory leak and resource leak, and then we would have problems with kind of spinning it down, we will need to use weak. Like that's the go-to way to do it in Rust. So the client, all the code the outside code would hold reference to the client through the strong pointer, through arg. But the context we give to every module is a weak reference. So it doesn't prevent the outside client from being distracted, from dropping.
So it breaks a certain
So
dependency.
Sorry.
So weak is a non-owning reference. An arc is like it's like an arc without ownership.
Yes. So if you only have weak references, then the thing gets the thing inside gets destroyed.
And why does the inner
sorry?
Why does the inner thing need the weak? Like what does it accomplish by getting the weak?
It can upgrade it to strong.
Oh, okay.
So the inner thing can still access the client only as long as the client itself was not already dropped by kind of things that actually hold on to it. In our case, it's actually, it cannot really fail because when the client is dropping, we stop the executor, which will stop all the modules or something kind of like that.
So just to recap, like if we did this change and we didn't do the weak, we would have a circular dependency and it would be it would be kind of a memory leak, or it couldn't be dropped. But by adding the weak, we're allowed to make this refactor, and we can do everything we could do previously. But there's just a little bit of an extra work. You have to upgrade the pointer from a weak to an arc when used in some scenario. But we can still do everything we used to be able to do, and now we don't have a circular dependency.
Even more. Like I want to put an even stronger constraint on the client, because the client is supposed to use the client module to use the context, and in particular the client itself will need to upgrade that reference, that weak reference, to the strong one. But I want to prevent the client from holding on to it, because if someone accidentally wrote a module in which they just want to be convenient and they don't want to call any upgrade or whatever, so they just call upgrade once, store it, and then they prevent this destruction of a client itself. And so I want the modules to only be able to get a hold to kind of this.
Okay.
And I have in So this is the thing we landed already, and here I was working already on that context. Where did I? Was it client context? Yeah. So kind of introduce client context that we will pass instead of all those arguments, and inside it will hold on to weak reference to the client, and there would be some kind of a client, let's say, and that will give you a client. Or some, yes, I will have to see if everything still works. But this would be like upgrade and this. I'm not sure if this flies. I might need to do it through maybe a lambda or something like that. We'll see. Or maybe, I don't know if borrow checker is going to be happy with it. Yeah, but for this to work, it needs to be possible to call all the methods on just like a reference to the client. And yeah, so in that PR we just landed, I kind of moved all the methods to this client inner, which is now just a client. So they're not on the inner arc, like on the client inner thing. Yeah, that has a nice property that before we had half of a logic on the outer client and half on the inner client. And it's kind of awkward jumping between them. And now we can have everything on just the inner client. And if something is supposed to be private, it just doesn't have a pub on it. Yeah. After this is all like kind of done, we could eliminate all those extension traits, and you would be able to call this on just mint client module. And if it needs to call like a client for some other things, it will just get a hold of the client reference and it will have it in the context. So then everything from those extension traits will move to the to just the main structure that the module author is supposed to implement. Yeah, there are some problems here that I've hit like which one is it? Oh, this is the old one. So here in it probably. Where are the errors? Yeah, here. So now there's, I'm back to the circular reference, and I might need to figure out some system to kind of overcome it, because the problem is that we initialize the client, we put it in an arc. So now this client is kind of immutable. But then we want to call the modules, each module to give it a client, and I wanted the modules to be able to save it inside without dealing with interior mutability. So I wanted this to be the only method called by mutable self. Yeah, but that's kind of impossible in the setup. So I think I'll have to compromise here in some minor way and hide it in implementation details. I'm not sure if I could pass it through a channel, and that might be the most elegant one. So instead of having a reference to the right away to the client weak, there will be a receiver on a channel that we're going to send the client weak when we're ready. And that's kind of what I'm thinking right now would be the way to break out of this impossible circular dependency. I mean, probably some amount of unsafe code would be able to accomplish this, but I want to avoid us touching any unsafe. So yeah, and that's kind of that's the summary of both two PRs. One was just a step to implement the other one. Yeah. Any questions?
I guess could you try to give maybe like a summarize? Does this affect like module development from any standpoint, or?
Yeah, it should simplify it. That's so as a module author, you will not have to make those awkward extension trades and implement them on the client. You will just have some kind of a client context object given, and you will find everything from the outside world you might need. So it should kind of make the experience easier. Yeah.
I don't have any other questions really. I'm curious to see how it goes. Is there anything
I'm a
else you
little
want to
curious
cover?
myself because the whole idea is like, I think it's a good idea, but implementation is tricky. So we'll have to see what's possible there.
All right. I mean, on a similar topic, we could go over the external seed idea, like from Sharia.
Yeah, I'm not sure if he's done with it. Okay.
I can talk about it briefly. Give me 1 second. Let me share my screen.
We do see your screen. We don't hear you talking though. We see your screen and we see Jitsi. Or at least that's what I see.
Hello, hello.
Hey, now we hear you.
Okay, great. Sorry about that.
Not a problem.
So let me go to Fedimint and open this PR. Secret. Refactor client folder. Pick and derivable secret. Yeah. So I'll just spend some time talking about the code changes are not that much. It's more about the philosophy. So as many of you may have seen, we have this concept of a root secret strategy, which is basically a zero size type, just an empty struct. And we have some implementations of this trait. So we have a we have a plain root secret strategy, which just uses random 64 bytes as like the entropy, and then generates the actual type is called derivable secret, which is what is the root secret inside the Fedimint client. And then we have another implementation of the trait, which is a BIP39, So it uses a 12-word seed for the entropy. And basically what was happening is that the build functions on client builder were generic over this root secret strategy. So that had two implications. One was that there wasn't really a way to provide a secret externally, because there was just no place to provide that. And the second was that these root secret strategies were a little bit opaque in that it was difficult to tell when they were generating a fresh secret or when they were loading a secret that was already in the database. Like that was kind of an implementation, a runtime concern inside of the build function in and of itself. So I'm sure you can imagine a scenario where somebody is just consuming Fedimint client in a CLI app or some front end or some other context, and they wish to have more control over the secret that is being used by Fedimint client. They want to provide the secret, or they want to derive it from some BIP39 outer seed, like hardware wallets do for multiple different accounts, something like that. So basically, what we did in this PR is that we decoupled this concept of root secret strategy from the build function of Fedimint client builder. So now it requires a derivable secret to be passed in, and no secret storing or loading happens within the build function. There are now side APIs to explicitly state your intent. Do you wish to store a secret within the Fedimint client database? Then you need to indicate that before calling build. Or do you wish to load a secret because you know that it's already present in the database? Then you need to indicate that intention before calling build. And in either case, once you have that entropy, which is used to obtain the derivable secret, then you're expected to actually pass in the derivable secret to the build function. So that's kind of the gist of it. I think there's a lot that can be iterated upon because we want to find like a good balance of less boilerplate, but also flexibility. And I think this was just a first stab at it to make it a little bit more explicit and expressive as to what exactly you want to do. And there's a lot of things we can do. So the root secret strategies are still left inside for convenience, because we do use them in the CLI package and the gateway package. So like those things haven't really changed how they function, but we don't really need them. So we are also free to iterate on what is a sort of a factory pattern for generating secrets, right? Like that's kind of that we can debate and reinvent a little bit there as well. So that's the gist of it, and I guess we can go over some of the changes.
So if I'm understanding it correctly, this is to basically allow for somebody to come in with their own secret and use it as a derivable secret, but that is separate from the standard root secret we're already using. Is this like is this going to be repeatable so you can have more than one secret, or not that I have a use case in mind, but I'm just kind of curious.
I'm not sure I follow more than one secret for the same Fedimint client instance.
I guess it doesn't matter because you just because it's derivable, you can just derive multiple from the one that you bring in, right?
I think the derivable secret is not really used for like deriving any sort of child secrets within Fedimint client. Maybe it is for some Mint related things. I'm not too sure.
That's part of the derivable. Like each eCache node that's generated, like we derive new nonces and What else? Also new binding keys from its secret. Like
Okay,
that's
so there we go. Yeah.
Okay.
Yeah. But in the use case you're mentioning, Ethan, it would be more like if a consumer or Fedimint client is managing multiple client instances or a client and some other projects that are not Fedimint at all and wants its own root secret and wants to be able to deterministically derive child secrets for their Fedimint client instances, for example,
Yeah.
then now they have the ability to do that, right?
Okay.
Yeah,
I
so
think
just
one
very
annoying thing in the past was when you wanted to use the same derivable secret for some external use cases. Let's say for generating a secure password for some authenticated API that you're also calling in the same application that also has the Fedimint client, then we had to provide an API that gives you access to the client's internal secret. So we don't really have to do this anymore. Or if you want to have multiple clients running in the same application, then this is really useful. So you only need one to back up one secret.
So you can see a little bit here. Previously, you would call client builder over some type, and everything happens as part of build implicitly, right? It's either going to load one if it finds one, or it's going to generate a random one and store it. But now, before you call build, you make that decision. So just to make this still backwards compatible, we're first trying to load it, and this is the type of the entropy, I guess, that is used in the plain root secret strategy. So this is, we just know that. So we try to load it. If we find it, great. But if we don't find it, then we generate one, and then we store it. And in either case, the responsibility is on the caller to provide the derivable secret. And here we're just using plain root secret strategy to turn that entropy. I'm just using the word entropy. I don't know if it's the right term, but we're using that to generate the actual root secret. But nothing is mandating us to use any of this strategy stuff here. It's just mostly for convenience and backwards compatibility.
So you can hand in any arbitrary derivable secret, right?
Yeah.
So something that occurred to me is we probably want to store some kind of a fingerprint of that derivable secret to prevent the user from accidentally trying to use a different one. And another thing is we probably want to derive the actual secret from the root secret that is passed based on the federation ID inside the client, the Fedimint client, and this is to prevent user from accidentally using it twice for different federations. Because there might be some we might leak secrets or stuff like that if you try to use the same derived keys for something twice in two places. So it would be best to make this impossible. And because of that, I think because the key derivation strategy will probably always include some kind of you have a root, like the user knows about one seed phrase or something like that. And then for every federation, you will want to derive the actual root for it. So if we move that responsibility to Fedimint client, then the outer code cannot forget about it. Yeah.
I like the idea that so in this case, basically in the code that I'm showing in line 305, regardless of the federation that you are joining, if you're starting with the same client secret, which is what's obtained in line 289, you would always have the same root secret. So I like the idea of somehow being able to make the actual derivable secret dependent on some data about the federation, so you're not accidentally using the same derivable secret for multiple client instances that correspond to different federations. I like that idea.
Yeah, so federation ID is probably the thing to use, and we can just derive one extra level based on the ID, and that should be good enough.
But I think we have to extend the API of derivable secret for that, because currently you can only use child IDs, which are 64-bit, and now we probably want something that's like 32 bytes.
Yeah, so we can add like a method derive with and then we pass some bytes.
And not impossible, just to keep in mind that we are expanding.
Might be good to make an issue for this.
I already created the issue for the hash in the DB, the root secret hash.
Yeah, and that's also I think it's a good thing to do.
One more thing. I mentioned it in the beginning. We can probably remove the external secret function now, unless it has already been removed in this PR, but I think it's not obvious that that's possible.
What function?
We added the external secret function to be able to use the same secret, like that the client already manages, for external applications, like in Fedi, for example, to derive the username and password for this chat server. But
I might not have done that.
Yeah, but now if you can hand in any derivable secret anyway, then you can just derive arbitrary other keys from your actual root secret.
Yeah.
And it just cleans up the API a little bit, because the client is already doing way too many things.
We do want probably some APIs for letting the external application store some data there, because the client already has a hold to the database. So for a lot of applications, it will be convenient. Like Fedimint CLI, for example.
I mean, you can get a database handle already, but that's independent of being able to get a derived secret from the client's root secret.
Do we have a good partitioning of the database namespace so they don't accidentally conflict with each other? So we might want like an API where we hand to the external client isolated database with some prefix that we guarantee we're not going to use, and then they could potentially do whatever they want with it.
Yeah, let's build it when we actually need it. Oh, I mean, we can open the issue, but it seems like a very low priority thing right now.
Okay. I thought we might already have like a need for it, but yeah, we'll see.
Okay. I mean, if you can see need already, then yeah. Can't you always just clone the database before you put it into the client? But then you don't have the isolation. That's a good point.
The isolation is like the only reason you have to do it.
Yeah.
And then like a client like Fedimint CLI will store the actual secret in that place. If we might have like APIs for that already, but they're kind of special casing the general principle. Because like the Fedimint CLI is probably one of the only clients that will not be a multi-federation client. All right, so it doesn't make sense for it to start an extra database file just to store the secret, and we might even have some other stuff we want to store.
Oh, you're thinking about storing the secret there.
Well, yeah, secret is like the first thing. That's why I was like, we already have a use for it, because
yeah,
we're moving the responsibility of managing the secret to the external user of Fedimint client library. But for Fedimint CLI, which is like the main client, there is no external place to store it. So we either add it or we stash it in the database we already have, which is kind of nice to have it in one file.
That makes sense. But then this functionality has to be available before the client is initialized. Otherwise, you can have a chicken and egg problem.
Yeah, I think the way we do it right now, we just have static.
Yeah. I think
yeah,
another good
static
way
methods.
of solving this is implementing like some sort of secret store trait, or like a trait that provides the secret,
Right.
and
Mhm.
then you could give this, like an implementation of this trait could own a reference to a database, or it could own the secret itself, like depending on how we want to implement getting the secret into the client.
Don't
yeah,
those two ideas kind of converge with each other?
Yeah.
The place to store something and the kind of a trait behind you put it, because we're not gonna be in that. Let's say we have a trait for secret storage. Are we gonna be doing anything than just storing? Dude, like you could kind of, I don't know, encrypt with a passphrase or something if it's specialized for a yeah, maybe we'll do something like that. Does it make sense? Like if you had a Fedimint CLI, let's say for whatever reason you're using Fedimint CLI to deal with federations, right? And you store your secret inside it, but you actually wrap it in a passphrase for security. So every
I
time
think
you
that's
run an
what some of the
operation,
Lightning implementations do, right? When you start LND, you have to enter a password.
Yeah, a lot
First
of
time.
kind of applications would require passphrase, like if you go GPG, SSH, anything kind of. So maybe we should do that as well. So in the Fedimint CLI would require an environment variable or a interactive password to actually unlock the secret.
Yeah.
And that's kind of more secure, at least if you kind of dump your disk drive somewhere,
Right.
and forget about wiping it. You have some protection.
But then you might actually want to encrypt the entire database, because the eCache is in there, and even if I'm not entirely sure if you could still spend it if you don't have the key, but we might be saving the derived secrets in the database anyway, unencrypted.
Yeah.
But yeah, quite.
It would be even better to encrypt the whole database. Yeah, but I don't know how hard it's gonna be to do on like the software level. Maybe GroxDB have even support for it, so maybe that's a better approach. Something to think about.
Yeah.
While at it.
All right. Well, I don't have anything else. We could stop a couple minutes early. Anybody else have something they want to dive deeply into in 7 minutes?
No, thanks everybody. We're gonna win.
Then bye. See you.
Take it easy, guys. Bye.
See you guys.